Hello everyone and welcome to the AI Research Roundup. I'm your host Alex, and today we are diving into some fascinating work on information retrieval. We'll be looking at a paper titled DeepRetrieval Hacking Real Search Engines and Retrievers with Large Language Models via Reinforcement Learning. Essentially, the researchers introduce a new way called DeepRetrieval to train large language models for generating better search queries. Instead of needing lots of hand-labeled data, they use reinforcement learning, letting the model learn through trial and error based on how well its queries perform. And the results are pretty striking. It significantly outperforms previous methods in areas like literature search, and even surpasses larger models like GPT-4o on certain tasks. Okay, so figure 1 here really drives home the point about performance. On the left part, we see a bar chart focused on literature search using real-world engines like PubMed and clinicaltrials.gov. You can see DeepRetrieval, that's the top bar with the yellow and purple sections. It's just way ahead of the other methods shown, like leads, and even the big commercial models, demonstrating really strong recall. Then on the right part B is a radar chart covering a bunch of classic information retrieval and SQL tasks. Again, DeepRetrieval, represented by that light outer line, generally covers a larger area, indicating better performance, often beating or matching models like GPT-4o and Sonnet 3.5 across these different benchmarks, which is impressive for a 3 billion parameter model. Okay, so building on those performance results we saw in Figure 1, Figure 2 here gives us a clearer picture of how DeepRetrieval actually works. You can see the process starts with the user's input query. The LLM doesn't just spit out a new query, though. First, it generates some reasoning steps internally, like a chain of thought within those think tags. Then it produces the final augmented query. That query is used for the actual retrieval, and here's the reinforcement learning loop. The retrieved results are compared against the ground truth to calculate a retrieval reward. There's also a format reward to check if the query is well formed. This combined reward signal is then used to update the LLM, making it better over time. Okay, so we just saw how DeepRetrieval generates queries using that reinforcement learning loop. Now, Figure 3 dives a bit deeper into what the LLM actually puts into those queries, specifically looking at something called knowledge injection. This is where the model might add information it already knows, maybe even the answer itself, into the search query it generates. This figure breaks it down for 3 different datasets, NQ, Trivia QA, and Squad, comparing DeepRetrieval, which is labeled ours against other models. The bars show performance. H at 1 and H at 5, both with the injected knowledge included and with it removed, which they call clean. The little pie charts at the bottom show how often each model actually injects knowledge. What's interesting is how DeepRetrieval adapts. It injects quite a bit on Trivia QA, less on NQ, and very little on Squad, suggesting it learns when this strategy is helpful based on the task. So we saw how DeepRetrieval generates queries and uses knowledge injection. Now, Figure 4 shows what happens during the training process itself. Up top in Part A, the length of that internal think step we mentioned generally decreases as training progresses for both models, shown after an initial spike. Part B tracks the rewritten query length, which fluctuates a bit more. And importantly, Part C shows testing performance steadily improving over training steps. You can see the models using the think step. Llama and Quen generally perform better than the Quen model without that internal reasoning step, which also seems to plateau earlier. So we've seen how DeepRetrieval learns over time. And really the key takeaway here is how reinforcement learning can teach these large language models to be much smarter about querying actual search engines and retrieval systems. This is pretty important for improving things like retrieval augmented generation, making AI more effective at finding and using real-world information. Well, that's all for this week's AI Research Roundup. Thanks for tuning in. I'm your host, Alex.